Let's continue our lesson. So in previous lesson we said that if we have a position time graph, then slope will give us velocity. Velocity equal to slope. Slope means tangent alpha. So these are some methods to solve quickly the problem. The second method related to this kind of graph methods is area method. So if you have a velocity time graph, so this part is very important. So you should have velocity time graph, then area under the graph, area under the line. So in this case it's green, for example. This is how velocity changes for this object, and the area under this line will give us displacement. So this triangle, right triangle basically, will be equal to displacement always. So for position time graph, slope equal to velocity. For velocity time graph, the area under the graph will be equal to displacement. For example, for this problem, area of this blue right triangle is equal to two sides. We need to multiply two sides, so 3, this part 3 times 12 divided by 2, because this is a triangle. So answer will be 3 times 6, which is 18. So 18 meters, this will be displacement. This is a displacement, not distance. This part is very important. Question: we have a particle starts from 10 meter. So this is initial position basically, and moves with the velocity graph shown in this figure. So does this particle have turning point? If so, at what time? So what is a turning point? Turning point means that it should change its direction. So it should stop, velocity should become 0, and it should go back. So I think answer will be yes, there is a turning point, and at 1 second, because here as you see velocity becomes 0. Before 1 second velocity was negative, it was moving to the left side. Then suddenly stops because velocity becomes 0. Then velocity becomes positive, it means it's started moving to the right. Part A, answer will be time equal to 1 second. Part B, what is object's position at 2 and 4 seconds? So what we said in previous cases, we said that if we have a velocity time graph, then area under the line will give us position, not position, displacement. So 2 seconds. So what is the area under the line? Basically this is the line, so area is this part. And this area will be negative because this is under the 0 level. This part will be positive, and it's obvious that these two areas are equal to each other. Basically displacement will be equal to 0. No displacement. No displacement, it means it comes back to the initial position, so its position will be equal to 10 meters again. So this is when time equal to 2 seconds. So area under the 0 level will be equal to negative. Now question, second part, find position at 4 seconds. Then 4 is here, so we need to find total this area, and we should add this area. This area of course will be negative. So this area equal to what? Area of this triangle, minus 4 times 1 divided by 2, it's negative 2. Area of this part is 3 times height 12 divided by 2, so 3 times 6, which is 18. So total area will be equal to negative 2 plus positive 18, it will give us 16. So time equal to 4 seconds, displacement will be equal to 16, and we know that displacement equal to final position minus initial position. So 16 should be equal to final position unknown, initial position 10. So final position will be equal to 16 plus 10. Final position will be equal to 26 meters. Okay, now let's come to the acceleration. Motion with constant acceleration. Unit, SI unit, international standard unit, is meter per second square. What is acceleration? Acceleration is the rate of change of velocity and measures how quickly or slowly an object's velocity changes. So when you hear something about acceleration, it means velocity is changing. This is what you should know. And the average acceleration during the time interval is equal to change in velocity divided by change in time. So change in velocity you should divide by time. Graphically, acceleration is the slope of straight line velocity versus time graph. So let me explain this part. So first of all, we should draw a velocity time graph. So for example, like this. Velocity time graph. Let's say we have this kind of graph. So what says here? It says that acceleration is a slope. What is a slope? Slope is a tangent alpha, as you know. So this slope will be equal to acceleration for this kind of graphs. This is very important. But don't forget, you should have velocity time graph. For velocity time graph, slope will be equal to acceleration. So don't confuse with previous one. In previous case, we had position time graph. In that case, slope was equal to velocity. Acceleration, like velocity, is so it has a direction, basically, is a vector quantity. Acceleration has a direction, so it's a vector quantity. Quick question. A car, let's say, slows down. Slows down means velocity is decreasing while moving away from the origin. Origin here, zero origin. It's moving to the right side, but it's slowing down. What do the position and the velocity graph look like? So position graph, so let's study what we can tell about position graph. Position, initially it was here, then position increases because it's moving to the right side. So position increases, somewhere it will stop. So position, after some time, position will not change. But initially it will increase because it's moving to the right. Position increases. Initially it was zero, increase, positive increase. Then it should remain constant. So A is wrong because here position is decreasing. So it's becoming negative. It means it's moving like to the left side. Here initial position was not equal to zero. Then it becomes zero. It means initially, let's say it was 10 meters, it was here, then after some time it becomes zero. So it means it's also moving to the left. No, it's moving to the right. Now let's come to B. Here, yes, this is correct because initial position was equal to zero, then increases, then it becomes constant. Constant means position is not changing anymore. So answer can be B or D. Now we should compare velocity. We know that it was slowing down, but it moves to the right. So velocity should be positive always because it's moving to the right. So if you pay attention to the graph, answer B, velocity is negative here. Yes, so it's always negative. It means it was moving to the left, not to the right, which is wrong. So answer will be B. Velocity was positive always. Initially it was moving faster, then after some time it stops. So answer will be D. Another question, similar. A car speeds up, velocity is increasing towards the origin. So it's moving to the left and the velocity is increasing. What do position and velocity graphs look like? So initial position is somewhere here, so it's positive. After some time it becomes zero because it's moving towards the origin. So answer, I think it can be A, because this is the correct C is also correct. Initial positive, then becomes 0. This is a wrong. Position becomes negative. In order to be negative position, it should pass 0 origin. Here also wrong, because initially it was 0, then it goes to the right. Now let's come to the velocity. Velocity is increasing, but to the left, so velocity should be negative always, and increase. So answer is C, because only here we have a negative value. Here it's positive value, so A is wrong. Another question related to the acceleration. Here is a motion diagram of a car speeding up on a straight road. It's speeding up to the right, to the left, sorry, to the left. This is a starting point, and this green arrow shows the velocity. So size of this green arrow increases, so velocity is increasing. So basically it's accelerating to the left. Question: the sign of the acceleration, of course it's a negative. Why it's negative? Because our x-axis is directed to the right, so everything looking to the right. For velocity, it can be acceleration, it will be positive. If acceleration and velocity directed to the left, it will be negative. Yes, or we can say it's speeding up to the left. It means acceleration also directed to the left, and left side is always negative. Question: we have a velocity time graph given. We need to draw acceleration time graph. Time, acceleration, let's say 3 seconds, 6, 9, 12. So this is a velocity time graph, so we need to pay attention to the slope, because for this kind of graphs, slope will be equal to acceleration. So here between 0 and the 6 seconds we have a constant slope, angle is not changing, and this angle equal to tangent angle equal to opposite side 6 divided by 6 base, so slope equal to 1, 6 over 6, 1, so acceleration equal to 1, and this acceleration is positive because slope is positive, so 1 during the first 6 seconds, positive 1 because slope is positive. Here slope is negative because it's going downward, and we need to find this angle, basically this angle, which tangent alpha. This will be slope and this will be acceleration, and it's obvious that it's negative because it's going downward. So height equal to 12, base equal to 6, 12, 6, difference is 6. So tangent alpha or slope equal to 12 over 6, which will be 2. Of course, negative 2. So between 6 and 12 second, acceleration is negative 2. So this is a acceleration time graph. Now let's come to the kinematic equations of constant acceleration. So till this point we learned how to calculate acceleration by using graphs. Now let's try to explain in terms of equations. So we know that acceleration is a change in velocity. So let's say acceleration equal to 2 meters per second square. What does this mean? This means velocity increases or decreases. If it's acceleration, decreases by 2 each second. Let's say initial velocity was equal to, for example, 3. After 1 second, velocity will become 5. After 1 more second, it will become 7. After 1 more second, it will become 9, etc. It means we can come up with this kind of equation. Final velocity equal to initial velocity plus acceleration times time. Basically, we can make it like this simple. So delta t is a change in time. Basically, let's say if you want to find velocity after 2 seconds, just use 2. So that's why I will use just t. So for example, here, this is at 0 time, after 1 second, after 2 seconds, after 3 seconds. Yes? So after 3 seconds, velocity equal to 9. So let's find this velocity by using this equation. So initial velocity equal to 3, acceleration is 2 after 3 seconds. So as you see, 3 plus 6 will be equal to 9 meter per second. So for motions with constant acceleration, you can use this equation to find its velocity. Now we are still considering the motion with constant acceleration. We know that velocity time graph, slope will be equal to acceleration, and if you have a motion with constant acceleration, then slope should be also constant. So you should have this kind of straight line. Now this is velocity time graph. It means area under this line should give us displacement. So let's write this equation. Displacement delta s or delta x, let's say delta x, equal to area of this blue shaded figure, which is trapeze. We can say this area equal to this part, this area, which is let me use t instead of delta t, t times this part is initial velocity. So this is initial velocity, plus this is area of this part, plus we need to add area of this triangle. Area of this triangle equal to what? This time times this part. This part is change in velocity. So basically time times v final minus v initial divided by 2. So this will be equal to displacement. So let's write it in this way: v initial times time plus, so pay attention to this part, v final minus v initial. In previous case we said that v final equal to v initial plus at. So final velocity minus initial velocity actually equal to acceleration times time. So we can replace this final velocity minus initial velocity with acceleration times time. So here we have a time 1/2 times at, so it will be equal to a times square over 2. So this will be our second equation. Displacement equal to initial velocity times time plus at square over 2. Don't forget, this is the equation that you can use only if you have a motion with constant acceleration. So we have two equations: v final equal to v initial at plus at, and the displacement equal to v initial time plus at square over 2. So we have two equations for now. We can get third equation by combining these two equations. Let's continue our second equation. So let me take time outside of the bracket. So here we have initial velocity plus at over 2. We know that at equal to v final minus v initial from the first equation. So it means x equal to time times v initial plus v final minus v initial over 2. Or we can say that 2v initial plus v final minus v initial over 2, which means v initial plus v final over 2. And this time equal to v final v initial over a, acceleration. So we can say v final minus v initial over a, this is actually time times v initial plus v final over 2. So this part actually equal to V final square minus V initial square. This is a simple math. 2a. So this is equal to x. If we pay attention to this part, let's take 2a to the right side. So we'll come up with this kind of equation. V final square minus V initial square equal to 2ax. Or to make it simple, let's write it in this way. Final velocity square equal to initial velocity square times 2ax. This will be our third equation. Let me repeat the first one. Final initial plus at and displacement initial velocity 1 over 2 at square. Very important three equations that you can use only if you have a motion with constant acceleration. Let's solve this question. Example 2.11. Fred is driving his Volkswagen at steady 20 meters per second. Steady means constant velocity. When he passes Betty sitting at rest in her Porsche, Porsche instantly begins accelerating at 5 meters per second square. How far does Betty have to drive to overtake? We have two different kind of motions. First one is motion with constant velocity, so uniform motion. Second one is motion with constant acceleration, basically. So this is, let's say, let's draw our coordinate system position. So x, here is the origin 0. So Porsche was here. So initial position for Porsche is 0. And let's say Volkswagen also starts from here, but its velocity is always 20. So what we did, we choose that the initial position where Porsche is located as a 0, as a origin. Now Volkswagen is here, moving with constant velocity 20. And let's say Porsche will catch the Volkswagen somewhere here, let's say, and this position is x0. We need to find this x0. We know that Volkswagen is moving with constant velocity, so x0 minus 0, this is displacement for the Volkswagen, should be equal to velocity for Volkswagen, which is 20 times time. So basically x0 equal to 20 times time. Now let's come to the Porsche. Porsche's displacement also x0 minus 0, basically x0. And what we have initial velocity 0, we have acceleration. What else we have? That's all. Let me write somewhere here three equations. And we need to decide which one will be useful for us to solve this problem. So first one, final velocity initial velocity plus at. Second one, final velocity square initial velocity square plus 2ax, and the x is displacement here, initial velocity time plus 1 over 2 at square. Let's pay attention to the first equation. In first equation we have a 0 initial velocity, acceleration is given, time unknown, final velocity unknown. So we have two unknowns. Let's come to the second equation. Initial velocity is 0, acceleration given, displacement unknown, final velocity unknown. So two unknowns. Let's come to the last one. Initial velocity is 0, so we have acceleration and time unknown and displacement unknown. If we come to the equation for the Volkswagen, here also we have a time and the displacement. So it means it will be better to use this equation here, because we have the same displacement and the same time. So x will be equal to 1 over 2 at square x0, 1 over 2 acceleration 5 times square. So in order to catch the Volkswagen, they should be at the same position. Only in this case we can say that Porsche can overtake the Volkswagen. So it means 20 times time equal to 1/2 square. So this is a quadratic equation, so it means we have two possible answers in terms of mass. So let me subtract and let me say equal to 0. So 5t4 minus 1/2t equal to 0. First answer, t equal to 0. Second possible answer equal to, so this part should be equal to 0. So time should be equal to 8. Actually, both these answers are correct. T0 means at the beginning. At the beginning, they were at the same position, 0 position. And the next time, after 8 seconds, they again will be at the same position. So after 8 seconds, Porsche will overtake the Volkswagen. Free fall. This is also motion with constant acceleration. Here acceleration is equal to gravity, and this gravity is always constant, equal to 9.8 approximately. 9.8, and the direction is vertical downward, and we call it free fall. If it's a motion with constant acceleration, then it means you can use previous 3 equations. So for example, if you drop a stone, it will accelerate downward. So this orange one shows acceleration. Of course, this acceleration will be constant, it will not increase. So size for this green arrow is always same. Green arrow denotes for the velocity. Of course, it will accelerate and velocity will increase downward. Or you can describe it in terms of graph. For example, velocity in y direction. Y means vertical direction. You know, free fall, it can move only in vertical direction. So velocity decreases, it's not decreasing, it's increasing downward basically. So it was 0, then it increases because it's moving downward. But always we should use negative sign here because it moves downward. So what does it mean? It means we choose upward as a positive, downward as a negative. So let's say this is origin, this is a position in y direction. Since it moves downward, velocity becomes negative. For x, you know, right side will be positive, left side negative. For vertical motion, upward positive, usually downward negative. Quick question. A ball is tossed straight up in the air at its very highest point. The ball's instantaneous acceleration. Instantaneous acceleration means acceleration at that time. It's like instantaneous velocity. Is negative, and it's always 9.8. Negative 9.8. Negative means directed downward. And it's constant, because this acceleration does not depend on the object that you throw. It depends on the Earth. It depends on the planet, size, mass, etc. For our Earth, it's 9.8 and it's directed downward always. Downward, that's why we say negative. Read this question, example 2.13, and try to do yourselves. Please pause this video and let's say for 5 minutes try to solve this problem. Only then please watch the solution for this problem. I will continue now. So we have an antelope in Africa. Basically it's jumping, and during the 0.7 meters it can accelerate with 35 meters per second. Then it will be in the air, so it will continue its flight in the air, and under the influence of gravity it will come back. So question is, how high does it go? So let's say this is the ground, initial velocity 0 here, 0.1, and this is a point when its legs will be in the air. So only at this region, at this time, it can accelerate with 35 meters per second, basically, square. Then it will be under influence of gravity, it will decelerate and it will stop somewhere here. So here we have gravity, 9.8, negative 9.8. Negative means just direction downward. So we know that velocity at point 1, 0, velocity at 2, unknown, velocity at point 3, again it will be 0 because it will stop and it will fall downward again. So let me write this equation, final velocity square, initial velocity square plus 2a displacement. In this case, displacement is basically height. So let me write this equation between point 1 and 2. Final velocity at point 2 square, initial velocity at point 1 square, plus 2a x, and this x of course 0.7. So initial velocity equal to 0, v1. So velocity at point 2 square equal to 2 times acceleration 35, x is 0.7 meters. So v2 square will be equal to 2 times 35 times 0.7, 49. Or v2 equal to 7 meters per second. So, and this will be initial velocity for point 2 and 3. So we can say that v3 square, this is final velocity, equal to initial velocity square minus is coming from the gravity sign, 2 times acceleration here, gravity, times displacement. Let's call it x1. So final velocity again 0 because it stops. So 0 equal to v2, of course 7 square will be 49, 2 times 9.8 times x1, and this x1 equal to 49 divided by 2 divided by 9.8, it will be 2.5 meters. So this part, this distance, this height equal to 2.5 and this height 0.7. So total we can say it can jump, in total it can jump for 0.7 plus 2.5, which will give us 3.2 meters. In total it can jump for 3.2 meters. Another question, we have acceleration time graph versus time graph, initial velocity equal to 10. We should find velocity, final velocity at 8 seconds. So if we pay attention here, during the first 4 seconds acceleration is constant. Okay, if acceleration constant, we have 3 equations, we can use it. But further, after 4 seconds you see acceleration decreases. So in this case we don't have a spatial equations. So what we can do, we can use area method. So if we have acceleration time graph, then area under this graph will give us change in velocity. So basically v final minus v initial will be equal to area. Initial velocity is given, so final velocity equal to initial velocity plus area. So first of all we need to find this area. So this area consists of this kind of rectangle and a triangle. Area for the rectangle equal to 4 times 4, 16, and the area for this triangle is 4 times 4 divided by 2, it's 8. So total area equal to 24. So initial velocity equal to 10, 10 plus 24, answer will be 34. Final velocity will be 34. So sometimes we can use these kind of methods.